All right, now we have Margaret Mitchell, who is a researcher based, okay, I need to read my notes, sorry, who is a researcher focused on the ins and outs of machine learning and ethics-informed AI development in tech. She is driving forward towards the work in ML, machine learning development, data governance, AI evaluation, and AI ethics. And she recently received the recognition of being in the list of Time 100 most influential people in 2023. So welcome to the stage, Margaret. We are excited. We are honored to have you here on stage as PyCon US keynote speaker.
Hi, thank you for the introduction. Thank you all for having me. I really appreciate the masking, even looking out in the audience. I see basically all of you are wearing masks. Thank you for that. I'm going to have to give my talk today behind the podium instead of walking around because a few weeks ago I broke my leg. So it's been an interesting thing traveling. I highly recommend these little knee scooters. I was like the talk of the airport. Everyone was so jealous that I could get through the airport so quickly on this little thing. But anyway, so it goes, and thank you all for coming. So I've been programming for a long time, an uncountable number of years. And my first introduction to computing was on a PC in the early 90s when I was in elementary school. And my flow would go basically like this. You'd turn on the computer, you'd wait, then eventually it would start to say that it was starting MS-DOS. That's when it got really exciting. There'd be a bunch of stuff that little me didn't really care about. But then you'd get to the goal, C:\\. I had a friend who taught me that you could clear the screen, and then the world was your oyster. So my first experience with programming was simple echo, and I found this fascinating. And this was sort of before the internet was much of a thing, so I spent most of my time doing this on the computer. But it was pretty fun and fascinating, and I was just hooked. So by the mid-90s, the World Wide Web looked kind of like this, in all of its sort of 32-bit glory, I guess. And I was actually able to connect with, this is what Amazon looked like at the time, just to sort of place the time. People were really into HTML color and animation. And I was able to join America Online, where I met a bunch of fellow nerds, and we started getting into programming websites together. So that brought me to my first experience with programming, where I learned HTML5 at the time, and was able to create, as you can see, much more mature work than I did when I was younger. So by the late 90s, I was very much into website design and object-oriented programming. This was all self-taught. It wasn't really much of a thing at school. But I used a service called WebMonkey to teach myself how to make interactive websites like Ask Satan, which would give you your fortune, and other little games that I would give to my friends as gifts, like here's a little website for you, although it was probably a lot more fun for me to do that than for them. So by 2000s, in roughly 2000, I began getting into compiled languages, starting with C++, where, after I had nailed the fundamentals of heap sort, or whatever it is, I started making games again using Visual C++, and was exciting to my nerd friends for a hot minute. Eventually, I landed my first real job, where the language was Tickle. Basically, Tickle is something that's used in speech processing, and my job was working in natural language processing and speech processing, trying to do things like diagnose whether someone might have mild cognitive impairment, which is a precursor to Alzheimer's, by using their speech stream. So I got pretty familiar with Tickle, as well as scripting languages and Unix utilities like sed and awk, which I still use to this day. For those of you who aren't familiar with awk, highly recommend. You can get a lot of language text processing stuff done. One guy agrees. You can get a lot of stuff done super quickly. It's really handy. When I was ready to go to grad school, I had the opportunity of figuring out which language I wanted to program in. They were pretty open about what languages you could use for different programming assignments. And so this was a pretty straightforward decision for me. I was embarrassed to say that my primary language was Tickle, and so I decided that my primary language would become Python, because Tickle sounds lame and Python sounds cool, and that was my complete reason for getting into Python. But I found it super intuitive. I just naturally took to it, and I was sort of off and running in machine learning at that point. In 2011, I used Python to create one of the first image description systems. So this is somewhat relevant now as generative image and text-to-image models are coming into sort of popular understanding. At the time, it was really niche. Computer vision systems didn't work. And so what you had to do was essentially take the things that the vision system had the highest scores for and intersect it with the language that was most likely, and essentially use that to generate what the output was. And this was when I discovered YAML, yet another markup language, which we used to pass around different information from the computer vision system and reading it in as JSON. Throughout grad school, I picked up some more things here and there, but primarily was working in Python and with the NLTK for language processing. I went on to get a postdoc, where I primarily coded in Java and Perl. I really hate Perl. I never used Perl. I really didn't like it. But there you go. Anyway, so I went on in the rest of my career. You pick up things as you go, but it's basically just been learning Python packages. Although I've had reasons to learn other languages. Throughout industry, they use Python. So at Microsoft, I had to do some C#, but most of my prototyping was in Python. Google was all Python, TensorFlow, scikit-learn, and Pandas. And recently, I've joined Hugging Face, which was using Streamlit fairly heavily when I joined. And now Gradio actually joined us. So Gradio has become our main way of putting out demos. But I wanted to sort of give this timeline a bit to talk about some of the things that have emerged for me as most important in computer science and in machine learning, and now what is called AI. It's been a little bit of a challenge for people to work in machine learning to start saying they work in AI. It's a little bit roll your eyes. So I might use them interchangeably, but I mean essentially the same thing. So one of the big turning points in my life and how I came to work on ethics in machine learning was during my time at Microsoft. So at Microsoft, I continued to work on image description. At this time, it was deep learning had just sort of been proven to work well in computer vision. And then recurrent neural networks on the language processing side seemed fairly promising. So I worked, also still in Python, in putting together the output of convolutional neural networks, which was on the vision side, to recurrent neural networks on the language side, and ended up being able to create image description systems that surpassed human performance as measured by BLUE score, which really speaks to the difficulty in automatic metrics and how they don't actually quite capture what we want. And I was able to work on creating a language for people, or a program for people who are blind called Seeing AI. And one of the things that was happening at this time was I was trying to think about, okay, I'm working on image description. Why am I doing this, right? What is the image captioning task? Who needs that? And one of the obvious answers in discussions with other academics was, oh, this is useful for blind people. You could caption things for them, super helpful. So I thought, okay, I'll work with blind people and ask them. And it turned out not helpful. The kinds of things that people who are blind needed was fundamentally different than the kinds of things being optimized for in the image captioning task. And so this was really a wake-up call to me about the discrepancy between the kind of academic tasks that we develop as a way to play around with new models and new technology and the real-world use cases, and how they can be quite different. So, for example, someone who's blind doesn't need to know that they're holding a soda can. They know they're holding a soda can. They need to know what soda it is, right? They need to know if a tube is toothpaste or like preparation H. It's these sorts of things, right? OCR, logo, these kinds of things were fundamentally different than what image captioning, the field of image captioning was really thinking about, but really got at what they actually needed. Things like counting the number of steps when you're going downstairs, right? Completely over the radar, under the radar, over the radar, over the heads of people who are working on these sorts of things. I was asked if I could talk about gender as well, being like a woman in machine learning. And so I'll just sort of say for this slide that it was not a pleasant experience to work on this. It was super territorial, right? So deep learning was just becoming a thing. There were all these competitions. I maybe was the first woman to win a deep learning competition. I don't know, because people were super mean about it. People at Microsoft refused to share it. And I did not see that happening with my male colleagues and men in other companies as well. So I just kind of wanted to put this out there that it's possible that you're a woman in tech. And if so, if you feel like everybody hates you and isn't listening to you and is, not respecting you similarly to your peers, this is what happens, right? You're not alone. This is the experience of so many women. And you can continue on and eventually get to a place where you're recognized, but it's a lot more hard work than it is for men. At least it has been for me. So I'll just say that. I think that's nice of you. But in this work, this sort of image description, image captioning work, my switch to working with people who are blind really changed my way of looking at research, which is that instead of focusing on the tasks defined for some conference or some competition, think through what the technology that you're working on now could look like in 5 years, 10 years, 15 years, if it were to help people. Right? How should it evolve to get to some helping people stage? So for me, with image description, I could see that some foreseeable positive future would be helping people who are blind. And so I worked backwards from there to figure out what I needed to work on right then. And it was fundamentally different than what sort of the academy was defining. And this meant that now when I approached research, I was looking at it in terms of the long picture, the long story. Where's this going to go over time? Who's it going to affect? And using that to influence the kind of things that I worked on. And once you're doing that, once you're working on your projects from the perspective of foresight, then you're already working in the realm of ethical AI. Right? Because fundamental to working on ethics in AI is being able to think through the different use cases, think through how the technology can be used positively and negatively, including by malicious actors. And this fundamental thing of foresight is really not prioritized in tech circles as much as it could be, and it fundamentally changes the kinds of things that we work on. This also spoke to my desire to include those most likely to benefit from the technology in its creation. And I still do that to this day to the extent I can. And it, again, fundamentally changes the kind of things that you do, and I would argue helps to shape the path of development towards better outcomes. So shortly after image description work, I started working on storytelling. So here's where you give the system a sequence of images, and it spits out a corresponding story about them. Here are some example stories generated by different versions of the system at the time. And we found that it had this problem that it thought everything was awesome. We called it the everything is awesome problem. So, we could show it, for example, this is actually me and my friends at Thanksgiving this past year, and it would generate a story like, everyone was there, the food was awesome, the food was delicious, and it was awesome. And it turns out that this is a reflection of the kinds of things that people say when they're sharing photos, right? So the reason for this is that people tend to share pictures of parties, right, of celebrations, of marriages, these kinds of things, and talk about how fun and awesome it is. People also tend to share things that are beautiful and great, so like sunsets or views. And that makes a lot of sense if you think about it, since people tend not to share tons of pictures of sad things or tragedy. When's the last time you saw a bunch of photos from a funeral, right? These personal experiences that are dark and sad aren't things we tend to take tons of photos of and talk about online. So systems that are learning from this kind of data learn things like beautiful colors in a sky, and it learns that essentially everything is awesome. When in doubt, everything is awesome. And the moment that I realized my life was changing in my research was giving it this exact sequence. And I'll pause a moment to let you read it. But basically, I gave it this sequence of what's the Hempstead blast. And it looked at it and thought it was great. And I realized that if we started making systems like this autonomous, capable of acting out things, then in the pursuit of beauty and things that it mistakenly thinks are good, it could kill people, right? It doesn't understand the fundamentals of mortality, and it doesn't understand a lot of the things that we don't tend to share online, private information. And so looking at it, I could understand sort of why it made these mistakes, right? So you see, this is a great view. It's trained on views. It's learned colors are beautiful. When you take a picture of a sky, it's a good thing. And this was something that no one else was thinking about. And as I tried to sort of get people interested in this, it was sort of a hard truth that no one really cared. So it was sort of like, well, if no one cares, then I guess I have to, right? Like someone has to. So I started paying a lot more attention to the way that data affects everything that happens afterwards in the machine learning pipeline, and then what happens when it's deployed in the world. So this sort of problem occurs throughout text that we scrape online. And online text is the main source of models that we train for AI right now. So one study showed, for example, that counts in an analysis of web text were not reflective of the proportions of these things in real life. So for example, murdering was considered or would be learned to be much more common than blinking, right? There are lots of things that we don't say. We don't tend to say, I'm blinking, I'm breathing. I'm sure many of you are blinking right now. Right, but things like murdering, when that happens, that is talked about, it makes news, this kind of thing. And so this is a kind of bias that could creep into your system, affecting what it learns and understands. This problem is called reporting bias. It's one of the many biases that fundamentally shape what language models used in AI learn. You can see how this interplays with the machine learning pipeline by sort of taking it into different stages and paying attention to how these things propagate. So at this point, I think probably the machine learning pipeline is fairly familiar to this audience. First, you collect the data, then you train and test a model. You can add additional post-processing, such as selecting among a ranked list in order for the model to output an eventual answer. and then people see the output. But before we even begin the process, the data itself encodes a subset of human perspectives and a skewed set of human perspectives. What people choose to talk about and how they talk about it based on their experiences is shaped fundamentally differently in text than it is in our real-world interactions. And the idea that a data set can be unbiased misunderstands what a data set is. A data set is a collection of bias, right? Where we collect it from is a bias. The time points that we collect it from is a bias, as well as the people who are represented, that's a bias, right? It's not everything in the world for all time ever or throughout the universe, right? Some sort of, random sampling of everything of all time might be something like unbiased, but that's not what a data set is. A data set is a snapshot of something, right? So a data set, by definition, is a biased bundle. In natural language processing, a biased bundle of text. And this sort of basic thing really escapes people's understanding, I think, in machine learning. But if you can sort of wrap your head around that, this isn't a representation of the world. It is a biased, skewed snapshot of the world, then I think it's a little bit easier to prioritize some of the things that most influence people and will most affect people when machine learning systems are deployed. Within the data itself, before it's even collected, there are things like reporting bias. There's racism, there's sexism, there's stereotyping. There's underrepresentation of various viewpoints as a function of it being a sample and where it's sampled from. And then there's further biases in the way the data is collected. So this is where things like selection bias and sampling bias really come in. And the way it can be annotated. And this is where the sorts of compensation we provide to annotators really matter, the design of the annotation task, these kinds of things. So all of these biases are sort of injected at the start and then propagate throughout the rest of the system as the system then learns all of these different things. Once you're training the model, there's a whole bunch of other kinds of biases you can pick up. So this is where things like overfitting and underfitting come in, where your data and your loss function aren't really well matched to one another. There's also default and anchoring effects, where you tend to just sort of do what people do without really thinking through why you're making those choices. And doing the default or anchoring on just what you know without really thinking through why fundamentally affects the kinds of issues that continue to propagate in machine learning systems as people just sort of do what the last person did with this default effect. From there, with the generation, there's all kinds of further biases, so confirmation bias. I think we can see this right now with Microsoft and Google sort of insisting that these chatbots they've put out are useful for search. They're not useful for search. They're useful for lots of things like creative writing, learning English. Not great for search. But if this is your sort of way of getting money, then you kind of have a confirmation bias in trying to see like, oh yeah, this chat thing will totally work. And the fact that it's not factual, well, you know, we'll figure it out later, right? So this is the confirmation bias effect. And then people see the output, and this is when automation bias comes into play. There's a bunch of different biases, but one in particular that's relevant right now is the fact that people tend to agree with or believe outputs of systems that are automated, even in light of evidence that what's going on isn't true, because it comes out of a system, a very biased system, because there's math involved, right? There tends to be some perception that it's objective or correct. And so we'll tend to do things or believe things that aren't actually appropriate or correct based on the output of an automated system. And from there, the sort of actions we take, or in the case of deep learning models for language, what we then say online. So we have a recommendation system that gives us tweets and then the kinds of things that we respond to, right? This then can be swept up in a further machine learning model, further amplifying these sorts of effects further. And I like to call this bias laundering, in large part because I made this GIF and I'm really proud of it and I like to share it. But right. Okay. Thank you, guys. Oh, you're like a very nice crowd, I have to say. I usually talk at other, like, more serious conferences, I guess. Like, you guys are really laid back. It's wonderful. Um, so, cool. So basically, one of the punchlines here is that there's no such thing as having a value-neutral way to develop systems. If you don't think about values, if you have the default effect where you're just not thinking about it, that doesn't mean that there aren't values being encoded. It just means that it's these biases that we already know about, right? You're just letting them further propagate. And the input data set defines what we care about for the model. If the data set doesn't represent appropriately populations in the solution space, and you deploy it, then you're making the value judgment that some populations should receive worse performance, right? And so this is a continued problem, and I wanted to talk about this in part to encourage all of you who care about data. This has been an ongoing thing in the conference, to keep working on it. There's so much work to be done and lots of blind spots right now in the sort of things that are important. And I like to call this sort of situation the data bottleneck. It's the touch point of information flow from human thought to AI, but it's the source of an incredible amount of issues. In particular, there's not a way to have something like the most values or the ethical thing. What ethics does is it talks about how to think through different values and prioritize among them. And there are trade-offs in all decisions. So it goes back to what your values are or what the values are of the organization you're working in. For example, we might want to release open data sets, right? It helps with advancing AI, benchmarking, reproducibility. But this comes with trade-offs of lack of consent, perpetuating problematic ideas, the idea that all the data somehow represents people correctly when it doesn't, privacy, licensing issues, issues of compensation, consent, and credit for the people who created the data. And so these are just some of the things that are at play when we sort of have the default approach of releasing our data sets without sort of additional considerations. Not to say it's all bad, but to say that there's tensions. Anytime we make a decision, there are pros and cons. You might want to have a data set that's diverse. This has come up sometimes, trying to have a reasonable representation of different sorts of populations. But that comes up against tensions of exploitation and stereotyping. So I'll give an example of this. I really enjoy showing bad headlines of Google, because Google was mean to me. So anytime I have a talk, I try and slide one in. So this is this one. Cheers for bad headlines for Google. OK. But the point here, so basically, Google was trying to work on Pixel 4 face unlock, right? You look at your phone, it unlocks. And they were finding that it worked disproportionately well for people with lighter faces than people with darker faces. So the idea was, OK, we need more diverse data. We'll go out into the world and collect images of black faces, or people with black faces. But it was really the sort of objectifying, like, we just need the face. The person doesn't matter, right? And what ended up happening was a stereotype effect, where apparently the people who were interested in doing this, working on doing this, thought that the best place to go to collect a lot of black faces would be in Atlanta homeless areas where there's a lot of homeless people. And they didn't really give a lot of information to the people about what they were doing or why. They paid them $5 for a multi-billion-dollar company that would be benefiting from this, right? So, like, yes, diversity, but also massive exploitation, right? This is a kind of tension that comes into play when you're trying to optimize for one value and aren't really thinking about the larger picture. Right, so part of your choice when you develop and share data is to identify which of these are your priorities and the pros and cons of different approaches. If you follow a default bias, just doing what everyone is doing, then the state of the art means hitting on all of these issues: problematic amplification, creating dual use effects, exploitation, licensing and privacy issues, and stereotyping. That's the default, right? You all can change this, but this is the state of the art right now. So one of the key solutions to this is operationalizing data development. I think this has come up in the conference already, but essentially data development within machine learning is treated as a unexciting, unimportant, sort of silly task, even though data is the source of everything else that happens afterwards. So I've done a lot of work on what it means to have sort of responsible data set development. And it actually turns out that the way to do this is by having a ton of roles. So instead of one data scientist who's in charge of collecting and processing and then reprocessing and then going back because there was an issue and da-da-da, there actually should be a whole variety of people and steps that go into the project. So a data set requirements specification, what should your data set have in it? And this is where foresight is really useful, thinking through, given this kind of system I'm trying to create, what sort of data set is best set to meet goals of positive uses in 5 years and 10 years. A data set design document, which talks about sort of how you collect the data, the approaches there. The data set implementation diary, which is talking about what you actually end up implementing and why. A data set testing report, so this is stuff about understanding the data more, analyzing it, measuring data. And then a data set maintenance plan. So are you going to update it? Are you going to, for example, include opt-in or opt-out mechanisms so that the data set can be continually updated in light of the data creator's wishes? And all of these have a lot of further details, but this is just sort of a high level of something like what I think would help for more ethical data development. So here's the same thing as a picture, because I like pictures. But essentially, as you go through maintenance, you can redefine the requirements and sort of loop through this way, keeping on checking on how the data set is affecting everything downstream and updating your data set as is necessary. And one of the ways that I've been approaching this is the way that lets me do Python, honestly. So there's a lot of different roles here, but the one that I wanted of all these roles that I've been defining was the one about quantifying data sets. So I've been calling it measuring data. And basically, the idea is that when we have a data set, we can quantify it along a whole bunch of different axes. And it's weird that there really isn't a bunch of norms around what you can quantify in data relevant to values, relevant to populations, relevant to representation. These sort of mechanisms and ways to do it don't really exist yet. So it's a wide open area. And it lets you program ways to do it, which is fun. So here's an example that you can check out if you want. It's open source on Hugging Face, which is where I work now. I am basically only allowed to work on it if people go to it. So if you just want to go and then say, this needs work, that's fine. Basically, I need to show engagement. And unfortunately, data measurement just isn't a thing that the community largely cares about in AI. But here's the kind of things that you could do, right? So wouldn't it be cool if when we release data sets, we also had some basic statistics, like the number of web domains represented, the number of data instances with copyright information, the number and type of licenses. And the Washington Post actually, just a few days ago, released an investigative report doing just this for a common machine learning data set called C4, right? So the C4 has been around since 2019. And it was just last week requiring investigative journalism to provide these basic statistics. And they had to work with AI too to do it. Also, it was all in Python, yay Python. But the point is that this isn't a norm, and having to find out what's in the data sets that we're using within AI through the work of investigative journalists is maybe a situation where we can make some improvements. You can also do advanced statistics. So for those of you who are mathy, this is where it gets super fun. So I've developed a few approaches here. So for example, if you're modeling natural language is known to roughly follow a Zipf-ian distribution. And so you can actually measure this, and then this will automatically sort of tell you whether there are a lot of weird artifacts in your data. If it's not behaving like a natural language distribution, that's a warning sign that there's some crud in your data that isn't natural language that you might not want. Associations, very low-hanging fruit. That would be super useful. And then one of the hardest things is around social constructs. And this is where work on construct validity comes into play. So things like the severity of hate language. Like, what are these concepts and how do we measure them? Wide open. You all should work on it. Let me check my time. OK, cool. So I'll quickly jump into one of my favorite families of measurement, associations, so you can all see how easy it is and hopefully want to do this too. So basically, one of the issues in data sets is stereotypes, right? And stereotypes apply to different identities, different social identities. So if we were to put these social identities into language, this would be things like words for ability status, for age, for gender. And what you can do is look at what they tend to co-occur with in the data set, right? So all of these are vocabulary from the data set. We isolate the identity terms. You can write these, right? We know the social identity terms that are historically subject to discrimination. You can write these down. And then you can look at everything they tend to co-occur with. And then you can do a fairly simple thing of counting, right? So woman and lipstick, woman and smile. You can then look at comparisons, right? So man and lipstick, man and smile. And once you take some basic subtractions, you're measuring bias. Boom! I just got so excited, I like hit my glasses off. So simple, such low-hanging fruit. Nobody does this. Someone please do this. So this is just a simple co-occurrence kind of statistic. You can get much more advanced. So there's a whole world of math having to do with associations. Correlations are the one or the family of, there's a family of correlation measures. That's what people are most familiar with. There's also other kinds of measures like those based on entropy and mutual information. So normalized point-wise mutual information is one that I use. And it really helps automatically pull out stereotypes. Super easy, super fun. Not fun that it exists, but fun to uncover. And then you can use that to make your data sets better and remove really problematic stereotypes. So the point here is that, you know how we evaluate models? We should also measure data. So you should think of like evaluate is to model as measure is to data. That's sort of the headspace I've been operating in, and I'd really want the second part, measuring data, to become a thing. Once you have all this sorts of information, this is where data documentation comes in. There's been a lot of really cool work on how to do data set documentation. For those of you who are fans of metadata, this is where you can totally nerd out. So some of the examples are data statements, which is for natural language processing, data sheets, which get into details of consent of crowd workers and this kind of thing. And then data set cards is something that I'm working on at Hugging Face, which essentially just borrows from all these ideas and makes it a little more compact. And this does things like providing information about the sources, the languages, the curation rationale, the collection methods, the consent mechanisms, et cetera. And now you can use these things to decide among data sets, compare different data sets, as well as improve data sets. I was also asked to talk about the stack. I won't have a ton of time to do that, but here's an example of things that are in a data set card for the stack. So as an FYI, the stack is a bunch of GitHub repositories where it was collected with super permissive licenses, and we're also giving people the option of opting out. So it's sort of an experimental way of developing a data set where you try and make sure that people know that they're in it. We're also working on opt-in. That's a lot harder for large data sets. If you want to keep up with the state of the art, you essentially can't use opt-in if you're trying to look at your model performance. But by working on opt-in mechanisms, we can make this more of a thing that actually happens. So this is where you end up, in this dataset card is where you end up putting things like information about the curators, the social impact, all these sorts of things. And my work in particular, I just have a couple more minutes, so I think I'm right on time, actually. My work in particular is around what we call ethics and society at Hugging Face. There isn't one dedicated ethics team. Pro tip, if you're trying to operationalize ethics within your company, having one dedicated team ends up creating a bit of a rift. It can create sort of territorialism effects, and the ethics team can be seen as a policing force. So one thing that's really useful is actually to have ethics-minded people throughout the company who then come together to sort of share vocabulary and techniques and things like that and go back to their teams. So the group of us, we call ourselves Ethics and Society Regulars, and we have open source stuff up on Hugging Face as well if you want to check it out. I think let's see. Yeah, it's at hf.co/ethics. And so you can see some of the stuff we've been doing, for example, exploring bias in generative image models. So we have like Stable Diffusion and DALL-E. You can take a look at different kinds of groups and adjectives and see the differences yourself. Where we have a ton of tools for this kind of stuff, and since it's open source, we're really happy to get more, obviously. So some concluding thoughts. Python is awesome, so I hope that's been a theme throughout this. Most of, or all of the stuff I've talked about has been in Python. Machine learning models learn about the world, usually using web scrape data, which is problematic for a whole bunch of reasons. And it's useful to have knowledge and control over what's in the data, and we can use Python to do that. Decisions of what to work on and how can be informed by thinking through different values and tensions and then how they play out over time. This foresight idea, looking forward 5 years, 10 years, how would this be the most beneficial and who should I be including right now to make sure that it is as beneficial as I want it to be? Data set construction as a whole can be way more rigorous. I really am trying to push the needle on measuring and documenting data, and I hope that this is interesting to you all as well. I work, by the way, at an open source Python company, so you can check out more at just hf.co. Okay, thanks.